So I'm going to lay some context about what we're doing at Snowflake, why we're using it, and then Rohan is going to go through the details of how we handle our data sampling in an efficient and scalable way. So the first step is, why do we use Snowflake? So Spectrum Labs, as you've heard Bryce talk about and Josh talk about before, we handle a lot of data throughout the day. We handle over 600 million messages, I think maybe over 700 million messages each day across over 20 languages. And those messages contain the sort of user-generated content, which can be varying in length, but also a lot of metadata about who those users are, what they're trying to do, and who they're interacting with on the different platforms. So we're generating sort of terabytes worth of data all the time. Now, Snowflake itself, for those of people who know or don't know, it is a large-scale distributed database that allows us to store a lot of data there and scale our compute needs to make sure that we're doing so efficiently for sort of our money and different pieces. But it also allows us to very easily segregate controls and access for our clients by different data types and dynamically update those different schemas and tables and views to efficiently work with them without having to work with a database administrator all the time. And lastly, I think one of the major pieces of this is that the access controls and privilege configurations are something that we can manage consistently via Terraform, so we can keep our platform engineers and other engineers in line on these things so that we're able to keep them up to date as we need as we go forward. Now, we have a lot of data there in Snowflake and what we're doing with it. So as everyone here probably knows, machine learning needs a lot of high quality data to do the work it needs to do. But just to dig into exactly what we're doing with Snowflake is that first off, that data allows us to build reports and analytics about our clients for our needs and their needs, as well as build analytics across our clients, so across our platform with the different types of interactions we're using, types of models and tools we're using. We also our data operations teams need to access that data so they can get it labeled for ingestion to train models. So they need to be able to find which data we've ingested from our APIs and other pieces, and how to get that collected, collated, and sent out for labeling. Our data scientists themselves need some of all that data to actually do the train models and classifiers for our work at different levels, different levels of scale there. And then finally, as we are releasing these to our clients, our validation and release teams need to understand the impact of our newly trained classifiers and models and configurations on our clients' performance. Because what we don't want to do is roll out new products and have our clients' behaviors drastically change over the course of what they're doing. So we want to make sure that we know exactly what impact this will have on live traffic. So we're doing a lot of smoke and regression testing to make sure that these things are all happening. But that requires us to have consistent and repeatable data access for those different processes. And so how do we actually do that? How do we get that data access? So right now, for those who mentioned Snowflake, there are a lot of different ways to get data in and out of there. We primarily interact with SQL. That's sort of the most common way this is done. But as anyone knows, the levels of skill, comfort, and ability with SQL varies across teams and even in teams across time as you hire and get new engineers, new data scientists, new machine learning engineers. Their comfort with that data access can be wildly different. And some, also their confidence in it. Teams, as we've seen, will often develop their own internal workflows around how to deal with that data if you let them. So they may stand up their own visualization tooling. They may build their own processes with Jupyter notebooks and spreadsheets and other tools that allow your data to leak into different areas, but also allow things to just be inconsistent. And because of that, quality control is extremely challenging at scale. So we want to make sure that the data that teams are accessing and storing it is done safely and securely. If they're accessing the right data, and they're accessing the right data in an efficient manner. And so as we have all these different processes that will crop up, you have just different ways. It's not possible to do that at the kind of scale where we need to work on it. And so this is kind of the world we were living in. We had a lot of different ways that things happening there. And so the project that Rohan led for us, which I'll hand off, was about getting to data sampling at a scale the way we can.
All right. Hopefully you guys can all hear me well. So 2 qualifications before I begin. I think we have a cozy enough atmosphere here, so if anyone wants to ask questions or anything in the middle, just feel free to go ahead. The second is that I have some code on here, which is Might be tough to read, but if you have any questions or anything after, want to see some examples, then feel free to ask me after and we can go through it. But yeah, so I'm going to talk about kind of our pipeline for building stored procedures through Snowflake that allows us to sample data effectively. So yeah, to recap, what we want to do is produce this pipeline that'll like gather data from Snowflake that we can send to labelers to basically get labeled data that we can then use to train our models and send that to S3 as well. So the characteristics that we want out of this pipeline are pretty straightforward. We would like this pipeline to be really simple, which effectively stored procedures do by default. They're just a callable function that you can have within Snowflake, a one-line command for being able to produce the data that you need. We want it to be fast. That's very important because we don't want long-running queries on Snowflake warehouses to take a long amount of time. They can not only hamper like how quickly you want to iterate on models, but also pile up in costs, how much compute you may be using within Snowflake. We want it to be configurable, so we want to build our stored procedures with a certain set of parameters to allow us to decide exactly what data we want to sample for. These can be parameters like keywords that we're sampling in, date ranges, so on and so forth. And finally, we want it to be testable. This is really big because it's tough to test SQL natively, but being able to test stored procedures in a nice way is something that we've kind of built out, so that's nice. So what we ended up with, well, we got a configurable workflow for creating any stored procedure UDF or UDTF, which is a user-defined table function on Snowflake. So even though we started this project specifically for data sampling, we ended up with a process to create any stored procedure within Snowflake, which could be useful for many things outside of data sampling. And this came with a variety of different things to kind of build out this pipeline. But one thing was we all got really good at Terraform, which was kind of important. Being able to create resources for stages, which is where you stage data within Snowflake, grants for how certain users or service accounts can go through and access Snowflake, and AWS integration points, which allows us to send data to and from AWS and Snowflake, all done through Terraform, which was pretty sweet. It is a little bit complicated to like understand state and all that, but we were able to get it done. And the second thing was a nice CI/CD pipeline for being able to update artifacts on Snowflake on code merges, which was super important because it's not, yes?
Sorry, is there a reason why you decided to do all of that Snowflake-specific configuration on the stage that it runs in Terraform as opposed to data Snowflake, given that you got all in on Snowflake?
Yeah, one thing we wanted to do was just have like a centralized place for people to make updates to all the different things that you can do on Terraform. And being able to manage that through Terraform State let us have that consistency, especially across environments. And it was easy to kind of like test within like, a dev environment to see that certain changes that you make for Snowflake are good. And then using Circle CI and Circle CI actions, we could deploy those changes across different environments.
Thank you for pointing out that there's a Terraform provider. So when Max wanted, I just hooked up the database and went about my day. I didn't look, so thank you. But so you're doing all this management in Terraform?
Specific to like the interaction with code being sent to Snowflake, as well as the grants for users to be able to access and use stored procedures, yeah.
And is that only just to decouple, because do you have multiple Snowflakes, like do you have like kind of staging and broad Snowflakes, or do you have that, is that the idea of Terraform that you want to kind of?
Yeah, so we have dev staging and production environments, and so we're able to push out, test, and then roll those things out. Yeah.
That's correct.
Yeah, I think that's what makes sense.
And we're also using Terraform to do configuration at other pieces around the different systems. So it's a skill that a lot of members of our engineering team have, but they're platform engineering teams. So leveraging that allows us to do the different management environments. I wouldn't say easily, because it's Terraform. But
Yeah, we've definitely
relatively
gotten
easy.
really acquainted with Terraform. And yeah, finally, the last thing we have is just a repository containing all the code that has the stored procedures as well as scripts to update them, and a module for testing these stored procedures as well, which was really fun to write. But yeah, this is kind of what the pipeline looks from afar. On the top left, we have all the code around the stored procedures using a library called Snowpark, which we'll get into. And it contains the code for the UDFs as well as the stored procedures. And once you make changes to these stored procedures, you can merge it in through GitHub. And then our CI/CD, Circle CI, will allow us to basically update our Snowflake environments with the updates to the code that you just made. And then in that process, we'll run our suite of integration tests to make sure that any changes that you've made doesn't break anything that we don't want to break. And finally, once all of that looks good, we can publish the stored procedures artifact to Cloudsmith, which is our artifact management platform.
I mean, just a division of labels. So those Snowflake, the step one here, that's not you guys. That's whoever needs to make those changes, developers or whoever, right?
Exactly, yeah.
Okay. So you really just, this is the framework that you hold.
That's right, yeah. So the first thing we're going to do is dive into that top left corner where we look at the code around stored procedures and UDFs, which integrate with Snowpark, the library for transforming data within Snowflake. So just diving into the internals a bit, I did not realize that I thought the whole thing would show up at once. I'm having to scroll through the whole thing, but that's fine. Yeah, so basically to write procedures as code, we use Snowpark, which allows us to write these data transformations in Scala, Java, or Python. We primarily focus on Scala, but it is really useful to have Python as an option, especially as we get into our data science teams, maybe using Snowpark more to write transformations with a language that they're more familiar with. But I don't know how many of you have worked with Spark before. Snowpark, as the name might suggest, is very similar to that. So the core abstraction in Snowpark is a data frame, which is basically a loaded table within Snowflake in order to make data transformations. So these could be things like mapping data from one object to another type of object. It could be limiting or reducing data into a new table, something like that. So very similar to Spark, and I think they're trying to create as much parity as possible there just for getting people to move over. One really nice thing about Snowpark is you could actually import third-party libraries to enhance any of the transformations that you make. This is just as an example for something that we do. So Spectrum has this module called the cleaner, which effectively transforms text in its dirty form, which may contain leak code or special characters, lots of white space. Bryce is over here who's written most of that in order to make it something that's text that's easy to train and work on. And we can import this cleaner module within our Snowpark code in order to use it in an effective way to produce data that we want for sampling. So, go ahead.
So, Snowpark and dbt, how do they play together, or is it if you have company doing dbt?
It's a good question.
I'm
not
trying to think,
too
'cause
sure.
we have both. So
Yeah.
I don't necessarily.
You can use dbt to orchestrate code that is written in Snowpark that executes within Snowpark.
Yeah.
So if you had the dbt pipeline across a bunch of
Your Snowpark code will be part of the dbt pipeline.
Yeah.
Yeah, so I guess
Yeah,
just
yeah.
orchestration at a meta level on there.
Yeah. Ours don't play with each other. They're both doing things independently at this point. But in theory
That's
they could,
right.
yeah.
dbt provides testing capability type of stuff, whereas the stuff for Snowpark is just think of it like instead of SQL, you're writing Scala that executes the Snowflake.
Yeah.
Everything else
Yeah.
it's just Snowflake's version of Scala.
Yeah. Something
Yeah,
like that.
and to add on that, one of the nice things that Snowpark lets you do is write code in modular and testable ways. So we can reuse a lot of the library functions that we have within our Snowpark library or add-on to build many different types of sampling queries. And it also allows us to test these functions to make sure that any of the transformations that we're making do exactly what we want, versus writing like hundreds of lines of SQL in order to sample some data, which we've had to do. Yeah, so, and oh, I missed one. And Snowpark can write out the final results of the data frame, which is obviously super important. Once we have data sampled, we can either write it out within Snowflake as a separate table, or we can write it out to a file on AWS, which is useful when we're sending these files over to our human labelers. And this is kind of what a really trivial Snowpark query would look like. You can see from the arguments, we're gathering the session info for how we're going to load data, as well as how we're going to save that. And we have the arguments for where that data is coming from and where we want to save that data to. The final argument here is just to count for the data that we're limiting from the table that we've loaded. But you can add any number of arguments here in order to specify what you want to do with this specific transformation. The first argument needs to be that session variable, but beyond that, you have kind of like full flexibility on what you want to do within this stored procedure. Does anyone have any questions on what this might look like? All right. So UDFs are pretty similar to stored procedures, except instead of producing like a table that can be derived from another table, what you're doing is instead you're getting a single scalar value from a row of data. And that can be useful because you can actually call these UDFs from within stored procedures to do some pretty complicated bits of logic around different types of columns. So we'll get into it with that example with the cleaner later. But basically, we can just create functions that you can't natively create within Snowflake, and then register them through code in a similar process that we do for stored procedures. And yep, lastly, we can call them from within stored procedures. So this is kind of what that cleaner UDF looks like. On the left, we can see the definition for how that UDF sort of is defined. We're importing the cleaner module, which is a third-party library, to actually do that cleaning through a dependency injection framework called Juice. And then we have a handler method, which is required for all UDFs in order to actually call that cleaner on top of two columns, which are the text and the language that we're doing the cleaning on top of. And finally, if we want to use that UDF from within a stored procedure, on the right, we have an example where we're specifically using this function called callUDF, which is offered by Snowpark, to call a registered UDF on top of the two columns that we're loading from the data frame.
So, sorry.
Yeah.
So the injector that I see on what I assume would be line 3.
Mm-hmm.
Can you explain the mechanism through which you can guarantee that that's like a one-time, once during a run or whatever frequency you want to be allocating that? What kind of controls do you have for that?
Yeah, that's a good question. So when we are like loading this stored procedure to run in the context of Snowflake, Snowflake actually like loads up this instance of like the library that you've registered with all of your stored procedures, and I believe it runs this this constructor once to create this object that then gets used for all instances of when you might call this UDF or this stored procedure with this specific like handler method.
Gotcha. Okay, cool. So it's a mechanism of just the documentation based data we're going to call this once.
That's right, yeah. Any other questions? All right. So to kind of like kickstart this process on how we actually send code to Snowflake, we could talk about creating the artifact itself that gets sent there, and how that kind of works in terms of the accounts that do that sending, where it gets sent to, and all of that. So the four things that we kind of need in this process, we need a way to create these code artifacts, which are jar files containing this Snowpark code. We need a place in Snowflake that can receive the code artifact. When we need a way to upload to that place that it can be received. And finally, we need a way to basically look at this code that's now in Snowflake and register all these procedures or UDFs to actual functions or procedures that may or may not already exist on Snowflake. That way, when a user may call this stored procedure or UDF, they're using the latest version of that. So looking back at that pipeline view, now we're focused on these two blocks where we're uploading the code that we built through Snowpark to Snowflake. So yeah, creating code artifacts. It's pretty straightforward if anyone's used Scala. If not, it is absolutely not straightforward. But we use the SBT assembly plugin, which is a nice plugin on top of the build tool SBT in order to create these jar files. Assembly offers us a lot of flexibility in terms of like what libraries we want to pick and choose and put within our jar, and the way in which we can merge dependencies if you have like conflicts across different libraries that you're using. So on the top left, I just have an example set of assembly settings that we're using for the different types of files that we may try to merge. And on the top right is the kind of the dependency definition for what we are using for our store procedure module. One important thing to note, it's probably really tough to see, but I'll say it anyways. The library dependencies from within that definition need to add Snowpark as a provided dependency, because Snowpark is provided at runtime within the Snowflake environment. So this allows us to actually like use the Snowpark functions within our code, but not actually pull that dependency into the jar that we've created, because that dependency will be there on the Java class path at runtime. And finally, at the bottom is where in our CI/CD we actually call the assembly to produce the artifact that will be then sent to Snowflake. So it's as simple as just calling SBT and then the module and then the command assembly to produce the jar file. And this is something that we can do locally too, to just make sure that everything works fine. And so we've hit our first Terraform interlude now. What we need to do in order to have a place within Snowflake to receive this code artifact is use Terraform to provision what's called an internal stage. So you have two types of stages associated with Snowflake. You have an internal stage and an external stage. An internal stage is somewhere where you can house basically code artifacts in order for you to call and use them from within Snowflake. An external stage would be somewhere where you may put like AWS S3 files or something like that in order for that data to be then imported into Snowflake. But for now, we're concerned with the internal stage, which is going to have all the code that we want to use for Snowpark. And yeah, so Terraform can create the stage by itself. So using the Snowflake provider, we can just basically provision the Snowflake stage along with all the grants that are associated with that stage, which is really important. Without the grants, you'll just create the stage in a vacuum, and you won't be able to do anything with it as a user or as a service account. So yes, the stage must be defined within a database schema. So you're not defining it like in isolation within Snowflake. You're associating it with a database as well as a schema in order for you to upload this code to. And yeah, the grants that you can use for the stage are your standard like read, write, usage, ownership. I believe in order to send code to this stage, you do need to actually specify both read and write in order to have this code reach there. And now we can get into uploading artifacts to Snowflake. So the upload can be run through a script that actually uses a SQL command that will take a local jar file and put it on to Snowflake using the SQL command. It leverages the Snowflake connection that we've already written in another library that's pretty straightforward to write. It basically takes in a set of environment variables, a username and password, a Snowflake account that you're connecting to, creates a Snowflake connection that then you can run a SQL query on, which is a SQL query on the right, to basically send an already created jar file to Snowflake, to a stage location. Two important things to note here. One is you can see in the SQL definition, we've set auto compress to false because we don't want to compress the artifact that we're sending. And we also set overwrite to true because the definition that we have, the name for this jar file, is going to stay the same across every single build. And so now, if we send the jar file with the same name to the stage, we want to make sure that we're overwriting it. So we're just uploading the latest version of the jar file with the same name every single time. go ahead.
You mentioned that Snowpark has separate configuration. Can you configure Snowpark separately in terms of Spark? I mean, how many machines, what is the configuration for each machine? Or it's kind of derived from Snowflake configuration?
So you can actually set the Snowpark version based off that dependency that we saw in that. Let me go back, I guess.
Yeah.
Yeah. Here we go. Okay. So it's really tough to see, I'm sorry, but on the top right, you can see in the library dependencies, we've added Snowpark as a library there. That library definition actually contains the version of Snowpark that you want to run in runtime in Snowflake.
For the compute power, it does run off the warehouses that we defined?
That's correct.
in
Yeah, and there are actually different types of warehouses you can run on Snowflake, and you can actually set a warehouse to be Snowpark optimized. And so you can spin up a whole new warehouse that actually optimizes for running these stored procedures with Snowpark.
Why I'm asking, sometimes Spark requires specific resources because your table might be big,
Yeah.
small records full,
Yeah.
table is bigger, and depending on which you actually have to make it.
Yeah, it's a bit of a balancing act, honestly. One thing that we noticed is like you can obviously change the warehouse sizes that you use to run these stored procedures, but they cost more money depending on how much compute they have. So it scales pretty linearly, which is nice, but you just have to make sure based off your company's needs, like how quickly you want this query to be run.
But bottom line, you can actually attach some specific warehouse to Snowpark, and then it can use this by to do this process.
Exactly, yeah.
And it's actually not just to Snowpark, it's by actual, every run can have, you can configure that.
Yeah.
Yeah.
So you said you can mark a warehouse as Snowpark optimized.
That's correct.
What kind of optimizations result?
I believe the plans that get generated from the stored procedure, which is similar to like, the plans that get produced for a Spark dependency graph, they produce different types of plans based off whether you're running in a Snowpark optimized warehouse or not. I haven't looked too deeply into that, but I have confirmed that it does run faster for our code. So
Yeah.
that's what I know.
Different instances, different methods.
Yeah.
Yeah. So the next part of this is basically how we're going to configure the procedures and UDFs in order to register them on Snowflake. So now that we have the code in Snowflake, we want to be able to look at each stored procedure or UDF that we have and say, hey, I want to update this stored procedure or UDF based on this new code that I've written. The problem is we don't have an automatic way to look through our code and be like, oh, I see you've added this new procedure, I'm going to automatically update it. So what we do is we just use config management to do that. So every time you may add a procedure or add a UDF, you'll update this config file with a list of arguments as well as their argument type and what the procedure name is. And it'll look through this config and see, if this procedure already exists within Snowflake, I'll update it. If it doesn't exist, then I'll create it. And we use type-safe config, which is a type of config library through Scala to do this. And by defining, the elements that make up this query, it's pretty easy to just like kind of interpolate it into a command that we'll see to actually do that update. And yeah, just looking at that real quick. So similar to that SQL command for sending code all the way to Snowflake, now that the code is there, we have commands to basically create or replace procedures or UDFs based off that config that we just saw. So on the top right, we have a command to re-register a procedure, which involves a create or replace, takes the procedure name, a list of arguments, and a list of specifications around this procedure. So that includes what the return type is, the version of Scala that you're using, and the two most important parts, the libraries that you're importing, which is the code artifact that we've sent. You can see that Snowflake procedures queries jar, as well as the handlers. So within the jar that you've sent, you have a bunch of different handler methods now that will execute different types of stored procedure queries. And so we just need to specify the right one to associate with the procedure that we're creating to just officially register it in Snowflake. And it's a very similar process for the UDF as well. So yeah, that's pretty much it. We iterate through all the different procedures or UDFs in the config in order to do this. So are there any questions on that? And so now we can get to actually testing these stored procedures. So we have a way in Snowflake now to send all this data, all these code artifacts to Snowflake, as well as register them, and so they're available for use within Snowflake, but we haven't tested to see whether or not it works. So that's where our integration test suite comes in, to just make sure that all the procedures or UDFs that we make work as intended. And they all follow a very straightforward format. So in order to run this integration suite, before all the tests run, we create some synthetic data in Snowflake through some database and schema that can be used as input for our tests. And then after all the tests, we're going to drop these tables as well as the schemas associated with them. And then within each test, what we're going to do is we're going to query using the procedures or UDFs that we've created, check that the query results correspond to what's expected, what you want to see with that output data, and then finally drop that output table. And we basically do this for all the queries that we make in all the different types of input data that we expect to see. So
that synthetic data, who owns it? How do you know? I mean, does it need to change every UDF, every different data changes? What do you keep all of that?
It's very possible. We generate all this data on the fly, though. So it's not data that we're reading from, say, like a client or some test. It's literally just data that we create in the module itself.
And how do you know how to generate it? Or is that if I create a new UDF, do I need to ship you I need to let you know that there is this type of data you need to generate? Or?
It's up to the developer. The data itself is pretty, like with our sampling use case, it's pretty applicable in all types of different sampling that we want to do. As an example, we can just generate like scores from 0 to 1. We can generate the different clients that we see. We can generate like whether it matches with some feature set data, different languages, different keywords, so on and so forth. So once we have that suite to basically create all this synthetic data, before the tests run, you can just decide what parameters you want to use to create that synthetic data. And so that's really up to the developer.
Yeah, and just like, this is Scala code in our case, just like the rest of our code suite, right, we have these unit tests, integration tests, checked for code reviews, and then as part of the build process to gate them. So in theory, they stay up to date pretty easily. In as much as developers write unit tests when you want them to.
Yeah, right. But yeah, so this is just, again, I'm sorry, this is, I know it's probably difficult to read, but this is like an example integration test and how it's sort of defined. We have two really important functions on the top left for executing the Snowflake queries remotely. One is basically executing a query and then getting the result of that query as a callback in order to check what the output of that query is and maybe run some assertions and whatnot. And the second one is just vanilla executing a query. So that could be used for something like creating the synthetic data. And so on the right, we have a wrapper for actually running the stored procedure. So this is something that we specify for each procedure that we create, basically just taking a list of parameters that you'll actually input to the query and then wrapping it around the query. And then finally, on the bottom left, we have what an example integration test looks like, which is basically executing the stored procedure and then calling a second query on top of that to just select all of the data from within the output of that query and see whether the result of that corresponds to what we want to see. So now that we've tested all of our data, all of these procedures are registered in Snowflake, we should be able to run this correctly, right? Well, we run into the gotcha now where the procedures may not be accessible to a user within Snowflake. This is because we have fine-grained permissions across Snowflake, so we have different service accounts, different types of users, different permissions, roles, whatnot. So in order to make sure that the right people can access and use our stored procedures, we again run into Terraform. So before we can actually start using the UDFs and procs, we just need to make sure that the right roles can use them. If we have, like, let's say, just as an example, a stored procedure that maybe only an admin analyst can use, but not necessarily an analyst, we can do that all through Terraform and the roles that we've created on there. So there are 3 types of grants that we are concerned with when it comes to running stored procedures. The first 2 are related to service accounts. So in order to, again, upload the code artifacts to the stage that we've created, we need to add read-write permissions to the actual service account itself. And this is like kind of parallel to adding that permission to the stage. And then we also need a grant for the service account to be able to create procedures and UDFs within that specific stage. And finally, the last but not least, certainly the most important one, is to actually have grants to allow users and roles to be able to use the procs and UDFs that we've created. So that, that picture from that last slide where we saw that that procedure wasn't available to the user, that all goes away once we create the grant for allowing the user to actually see and access the proc and UDF. So this is kind of what it looks like at a high level. On the left, we have the grant for users being able to use the procedures within a schema. You can see that there's a specification for the role. So all users that are associated with that role now will have access to be able to run the stored procedures within that schema and that database. So there's a lot of configurability with Terraform, and probably a nice way to maybe automatically generate some of these resources. But for now, this is how we have it. And then on the right, we have the examples for allowing service accounts, the grants, to be able to register the procs as well as to update the stage with the latest artifact.
Okay. And so I'm just going to wrap up and do a little bit of what the impacts downstream of all this is, because that was a lot of very deep technical stuff. I mentioned that we want to do this stuff at scale. So by having an API front these stored procedures in different ways, it allows us to build common user interfaces across different tooling, which in turn lowers the bar for individual users to access this data. Because we know what these procedures are doing, we know they're accessing the data correctly and safely, we're able to sort of democratize who can build tools against it. So that may mean allowing non-development teams. So we obviously have our application development teams, but having machine learning engineers, data scientists themselves, pilot and build small tools themselves that access this data in whatever way they think is interesting. But we know they're doing it safely, and they're doing it in a way that will not expose us to errors with accuracy or inefficiency. We also allow these procedures to control where this data is stored and how it is stored. So we can control the format of exports and the locations they get pushed into. So for security and logging and traceability reasons, we're able to put them into buckets that we know the access controls to, let's say in S3. And the formats allow us to use this data across different purposes. So we can generate these exports in with different tooling and then consume them in different places because we know that they're going to be in the correct formats with the right assumptions across those different pieces. And then finally, as we mentioned, this stuff is part of can integrate with our just for general development stack and processes and procedures. So as someone who's managing some of these teams, right, the idea that we're able to just use our normal CI/CD process, our normal code review and control process, our normal Terraform access control process allows us to be confident that as new team members grow, as different things happen, we can easily expand our footprint here in a way that scales pretty easily and doesn't lead to any risk. And then as Rohan mentioned this as well, because there are different levels of languages supported, our different teams as they grow with different needs, obviously we're mainly a Scala shop, so we have a lot of Scala developers, but our data science teams, a lot of people using Python. And so we're able to expand just the footprint of people who can update this. So we're able to do a lot of things at scale and sort of very safely and very easily, just because of this, we're able to do this with our normal set of tooling and the normal processes, with our normal set of reviews and controls. Yeah, and that's it. Yeah. Good job.